Right. I am Keith Chirkauer. I am an assistant faculty member at Purdue University, describing my work on urbanization in Indiana and the Great Lakes region. As part of our study, we used a simulation model to project land use change in a four-state domain, so Wisconsin, Illinois, Michigan, Indiana. Using 1992 as a base, we projected out to 2010 and then 2030. And then we used a couple of models to try and look at the effect urbanization has not only on precipitation but also on stream flow. And so we looked primarily at, so we used the RAMS model to simulate changes in precipitation. So we looked specifically at one storm. We have hopes to look at a few more storms. But we looked at one storm that passed across Indianapolis in June of 2007, if I remember correctly. And so that storm resulted in a fair amount of precipitation over Indianapolis, and so we used the RAMS model with reanalysis data around the boundaries and ran the RAMS model with land use from 1992, 2010, and 2030, and looked at how RAMS predicted precipitation and other atmospheric variables would change because of those differences in land use. Then we took the precipitation and ran that through a hydrology model, and the hydrology model we allowed impervious area to change based on the 1992, 2010, and 2030 land use model, land use projections. So that we could, and then we did a factor analysis to try and determine which was, in which cases, whether precipitation or impervious area fractions were more important. And what we found from that is that changes in impervious area are fairly straightforward in their connection to changes in runoff. And the spatial distribution, we're not looking necessarily at stream flow, but where there has been increased impervious area, we find more runoff from the precipitation events. The change in precipitation is not nearly as straightforward. Some of that has to do with, not only the shape of the city we were looking at, but all of the upwind conditions that have also changed. The specific storm we looked at actually seems to be getting a fair amount or seems to be highly affected by East St. Louis, which was in our study domain barely. And so what we find there is that the signal is much more mixed. Sometimes we're getting increased precipitation, sometimes decreased precipitation. We do find that the convergence over the city is much higher as it gets larger, but it doesn't translate straight into changes in precipitation. Part of the analysis also has confirmed that as we increase urbanization, we get we reduce the amount of hydrologic memory in the system, such that we're reducing infiltration, so we have less groundwater return flows, and so as we urbanize, we see a much shorter memory for the watershed systems. And then the final part of this poster is kind of where we're headed with this research. We've identified 3 more very good storms where we don't think we will have as significant an upstream or upwind effect on what's happening, and there is an observed change in stream flow for these events. So we think we will in fact see more of an impact on stream flow from these events. And then the last part of this project that we're trying to do is to look at uncertainty propagation through all of these models by using 3 different sources of 1992 land use data. Because we used one for all of our projections, but the other, there's the NLCD 1992, there's also a NLCD 1992 based on the 2001 procedures, and then we have one that was based on GAP that we used, and all of those have extremely different urban components, and so we're interested in how that change in urban area just between the 1992 maps will affect runoff and precipitation.
So when you're putting together hydrologic model,
Yes.
Regional atmospheric modeling system, right?
Yes.
And some kind of boundaries and an urbanization projection. Where's the weak link here? I mean, it sounds good to me, but I'm just curious.
Well, there's a lot of uncertainty in all of that. I think our biggest hang-up was trying to come up with a projection that worked with a map projection that worked with all three of the systems. As far as what the weaknesses are, well, clearly the land use change projections are based on what has happened over the last several decades. So rates of population growth, rates of urbanization, rates of deforestation, which may or may not hold true anymore, and based on a base map which clearly may or may not represent what is urban and what is not urban. So the atmospheric modeling has lots of uncertainty involved with it, and the hydrology model, also, I mean, they all have a great degree of uncertainty.
How does RAMS treat the surface, and how does that affect the way this turns out? You're picking up feedbacks from the storms and somewhere along the way through the RAMS.
Right.
And how sensitive is it to urbanization? I'm not even sure what urbanization is, too, which I think I get into the definition. I'm losing sight because we're talking about what? Indiana or Illinois?
Well, we're talking about in Chicago and Milwaukee and Indianapolis and yeah. So urbanization from the hydrology model perspective is mostly a matter of effective impervious area. So impervious area that is fairly directly connected to the stream channel, which could be through storm sewers or it could be through straight drainage into a ditch or a channel. From the atmospheric side of things, we have to be concerned about changes in albedo and heat retention. I mean, there's a fairly simple urban scheme running in RAMS, which is helping to represent the urban heat island effect. But yes, I mean, you've hit upon a very good question, because one of the differences between some of the 1992 land use maps is whether you count all roads as urban area or whether you don't. And that actually, in 1992, almost doubles the amount of urban area in the four-state region if you count all roads, if you force all roads to be part of urban, or if you only allow large urban areas to be counted.
How did you get into this line of work?
I'm a large-scale hydrologist. So it is an interesting study. I've been interested in land surface and atmospheric interactions, so this is an opportunity to actually do something with that. Most of my work has been kind of offline hydrological simulations.
So this is one of your rare occasions to put together all these systems.
Hopefully not so rare now,
yeah.
but yes, when we started, this was somewhat novel for all of us.
Great. Well, thanks a lot. It was very interesting.
Okay.